So this is question 12 from your homework. A researcher wishes to estimate with 90% confidence the population proportion of adults who think Congress is doing a good job or an excellent job. Her estimate must be accurate within 1% of the true proportion. So the first thing is there's no preliminary estimate available. Find the minimal sample size needed. So remember, if there's no preliminary estimate available, we're supposed to use p hat. It's got to be 0.5 by definition, which means q hat's got to be 0.5 by definition. So when we use the formula to find the minimum sample size, we have p hat, which is the sample proportion of successes, times q hat, which is the sample proportion of failures. Then we're going to multiply by the critical value z, and we're going to divide by the margin of error, and that's going to be squared. Now, remember, the critical value z, since those have been consistent, I went on and just wrote those down so we didn't have to go look those up in the table. So those are the most common ones. And I think we're just using the 90% one. So really, we're just using this one here, the 1.645 one. So in A, since there's no preliminary estimate, we're going to use 0.5 and 0.5 for p hat and q hat. So we have 0.5 times 0.5 times then the critical value z. Since we want to be a 90% confident, that's going to be then this critical value z is this 1.645. And then we're going to divide by that margin of error. And we want to be within 1%. So 0.01, that's going to be then squared. So using our calculator, we can go 0.5 times then this 0.5. And then in parentheses, we can go with this 1.645 divided by 0.01. And if we square that, we're going to get then this 6,765. But also, since there is a decimal here, by definition, the sample size is always rounded up regardless of what the decimal is. So this 5 will automatically get rounded up to a 6. So our minimum sample size will be then 6,776. So to be confident with this 90%, they want us to use a minimum sample size of 6,766 people in our sample. Now, part B says find the minimal sample size needed if you used a prior study that found that 18% of the respondents said they think Congress is doing a good or an excellent job. Yeah, it seems like nobody ever really thinks Congress is doing a good job. We seem to be always pessimistic about who's in office, it seems like. So N equals then, so notice how this is what the outcome was, is this 18%. So that was our successes, if you will. But remember, we also have to have Q hat. So the flip side of that, so remember that's like 18%. And the flip side of 18% would be like 82% or 0.82. So if we need to double check that, we can go 1 minus 0.18 to get the flip side, because remember that they have to add up to the 1. So then we still use the same critical value z, this 1.645, and our margin of error is still that 1%, and we're squaring that. So now we actually have some data. So notice how now we're looking for, instead of this 50%, basically, we're now looking at 18%, So let's see what that does to our data. So 0.18 times 0.82 And then in parentheses, we've got this 1.645. And we're going to divide that by our margin of error, which is this 1%. And if we square that, that gives us then this 3,994. But notice how there is a decimal. And regardless of what the decimal is, the definition said round up. So that goes up to a 5. So notice how if we were given some information, how did it affect our sample size? Notice that our sample size actually decreased. So with no information at all, our sample size was 6,766. But by having some data, we discovered that we actually don't have to have as big as of a sample size. Our sample size actually decreased in that problem. So that kind of takes care of some of the information in question 12.